All right, in this video, we're going to look at solving exponential equations. So we've practiced graphing them. Now we're going to look at solving them. So make sure you put today's date in the top corner of your notes. So before we get into solving exponential equations, let's just review some terms. So remember, when we're dealing with problems that have exponents, you normally have a number or a letter that's being raised to a power. So the official word for the large number here is called the base. That's the number that's being raised to a power. And the little number, the exponent, is called your power. So the base is the number that you're raising to a power. So when you're solving exponential equations, there's a couple steps to follow. The first step is to make sure both sides of the equation have the same side. So both sides of the equation should have the same base. So what that means is that number that's being raised to a power, that should be the same on both sides of the equation. If it's not the same, you might have to rewrite the base in a different form, and I'll show you how to do that when we look at those problems. If both sides of the equation have the same base, then your next step is going to be drop the bases and set the exponents equal to each other. So when we're dealing with exponential equations, we're going to have problems that have expressions with exponents in them that are equal to each other. In order to solve them, we want to make sure that the base number, the large number, is equal or the same on both sides of the equation. If it's not, you're going to have to do some changing, and I'll show you how to do that with some of the more complicated examples. If they are the same, then you just drop the exponents and you drop the base, and set the exponents equal to each other. And that's solving exponential equations. So here's an example of what I'm talking about, because right now this is just words. Let's actually start applying it. Let's say I gave you this problem. 2 to the x plus 1 equals 2 to the 9th. All right. Remember, our first step said that both sides of the equation should have the same base. So here, the base is 2, and here, the base is 2. If the base is the same on both sides, you drop the base and you set the exponents equal to each other. So all I'm really looking at here is x plus 1 equals 9. And the reason I can do that is because the bases are the same. And now this is a very simple equation to solve, right? I just subtract 1 on both sides and get x equal to 8. And that should make sense, because if I plug in 8 to my original problem, 8 plus 1 is 9, so 2 to the 9th equals 2 to the 9th. That's a true statement. Let's look at another example. Let's say I had 3 to the 2x minus 5 equals 3 to the 13th. Again, check to make sure that both sides of your equation that have the same base, and they do, they each have 3. So if this is the case, I can rewrite this by dropping the base on each side and just making the exponents equal to each other. And now I'm just solving like normal. By undoing. So I'm adding 5 to both sides and then dividing by 2. I'm using those inverse operations. Where it gets a little more complicated is when you have problems that don't have the same base. So we're going to look at a couple of those, but let's do one more example where they are the same base. Our last example with the same base be 5, 4 to the 4n plus 5 equals 5 to the n minus 7. So remember, our first step was to make sure that the bases are the same, and here the bases are the same. So I drop the bases, and I just take care of the exponents. So remember, you're just solving by undoing, so I want to get my x terms together, or my n terms together, and my numbers together. So I'm going to subtract this n out of here to both sides. I can't combine like terms because there's an equal sign separating these two sides of the equation. So I have 3n plus 5 equals negative 7. I can subtract 5 on both sides and then solve like normal. Are the same. The exponents equal to each other. Let's look at a little bit more complicated of an example. So let's say I gave you 6 to the 2x minus 10 equals 36. And then only to x. I'm not going to type in all of this. Able to see that initially by yourself, but this is a good way to kind of figure out the numbers that you could rewrite. I can solve like normal, make the exponents equal to each other. And then divide. 2 to the p minus 7 equal to 8. Two to the x says 2p minus 7 equals 2 to the third. So p minus 7 equals 3, and then I'm just adding 7 to both sides and getting p equals 10. For example, and then I'll let you work on these problems. 4 to the y plus 2 equals 16 to the y minus 3. They're not the same. So I'm going to see, is there a way that I can change 16 into a 4 so I can have them be the same base? So again, I'll use my calculator. I'll hit y equals. And instead of 2 to the x, I'm going to do 4 to the x because I want to see how I can turn 4 into 16. Hit second table, and then look for your number, and there it is. That's when the exponent is 2. So what's tricky about this one is that there already is an exponent on the 16. So I have to rewrite this as 4 to the second power raised to the y minus 3. 4 squared is still 16, but now I have to distribute this 2, so it makes it a little bit more complicated when there's an exponent on the number. So I distributed the 2 and got 2y minus 6. So I dropped the base, and then you can solve like normal. So I'll get rid of the y. 2 equals y minus 6. Add 6 to both sides. 8 equals y. Didn't happen over here. Okay, so